Hello, my name is Nothando Mangena.
I am Sepehr Madani.
I am Catherine Liu.
I am Aurian Maleki.
I'm Sujay Marisetty.
I am Nafiza Sepehr.
I am Avha Mohanty.
And I am Daniel Mousavi.
And we will give an introduction to the scientific method. From ancient Egypt, ancient Greece, to Renaissance and the modern ages, the scientific methodology has been used over thousands of years in different ways. Philosophers, observers, scholars, and so on all understood that scientific experiments required a general order to it. The scientific method is a framework of approach in any research process. The modern concept of the scientific method as we know it was coined by Francis Bacon. The steps to the scientific method is as follows: question, research, hypothesis, procedure, data collection, analysis, and conclusion.
The scientific method begins with an observation or a set of observations of the surrounding world. From these observations, a scientist can derive a question about the what, how, and why of those observations. For example, in the diagram on the left, we can observe that the roses in vases die fast. In that case, our question could be, how can we make roses in vases live longer? In general, the point of your question should be to learn more about that observation.
After we pose a question, the next step in the process is background research. This will help us gain more information on our topic and conduct the best possible experiment. We can also compare what has been done before and what has not been done. This will make sure that the experiment provides new results and we are not just repeating information that is already known.
The next step in the scientific method is the hypothesis. And so, what is the hypothesis? Well, the hypothesis is an educated guess or a prediction about what might happen during an experiment. This is where you have not yet started your experiment. Your hypothesis, instead, is based on the previous steps of this scientific method. In other words, you are using what you observed and also your background research to create this prediction. Now that we have briefly introduced what the hypothesis is, well, we can ask, why is this a crucial step in the scientific method, right? So the hypothesis allows you to start the next step of the scientific method, which is the procedural portion. And with this hypothesis, you can then create a plan to move on and actually test your hypothesis. That means you know what you will be doing and looking for in the experiment. And in the same vein, forming your hypothesis gives you focus and direction to experiment and helps you keep in mind your initial educated guess. So now let's make an example hypothesis. Most hypotheses are in an if-then format. Let's recall that question of how can roses in vases last longer? Your hypothesis or prediction could then be, if flower food is added to the water in the vase every day, then the roses will live longer.
Now that we have our hypothesis, let's move on to the next step of the scientific method, which is the procedure or the plan for our experiment. The procedure is the part where we can think about ways to test whether our hypothesis is true or not. Let's think back to our hypothesis. If flower food is added to the water in the vase every day, then the roses will live longer. Well, one way to test this is to separate out the plants we have into 3 groups. One group receives flower food on a daily basis. Yum. One group gets flower food once a week, and one group gets no flower food. And then we can record our observations on what happens to the roses every day as a result. This way, we're seeing what happens to the roses when we don't give flower food to the plants every day. We also have to make sure that when we're doing this experiment, we set controls. In other words, we have to make sure that we don't have anything else impacting the roses. That means we have to make sure the plants are in the same conditions, such as getting the same amount of sunlight and being at the same temperature. This way, we know that any changes to the roses is only caused by changing how often we give flower food to the plants.
The next step is data collection. This is where we make observations and record measurements for the experiment. In our rose experiment, this would involve measuring and recording the heights of the roses with different conditions. We can also make qualitative observations about the rose's health, such as the color of the leaves or the strength of the stem, to compare the overall health of each rose plant. Recording details during this step is very important because it will give us more information to make the correct conclusion for the experimental question.
Once we have collected our data, it is important to conduct precise and detailed analysis on it to understand the conclusions that we can make. The analysis in the experimental procedure can be quantitative and qualitative, and quantitative and qualitative tools can be used to ascertain such findings and conclusions. With regard to the quantitative tools of the experimental procedure analysis, they can include calculations, statistical measurements, bias reporting, probability distributions, confidence distributions, confidence levels, intervals, and the bounds that we can numerically ascertain our things. Any form of numerical comparison could also be characterized with regard to the quantitative tools. Now to the qualitative tools of our analysis, that could include verbal and logical comparisons, discussions of results, value levels, discussions of potential qualitative biases and how to improve their experimental procedures, assessments of our significance, future avenues, and any form of verbal or non-numerical kind of discussion. With regard to our plant experiment-based example, an analysis could include if our experimental outcome was that plants receiving fertilizer were able to grow much larger and faster than those not receiving the plant because of our p-value. That is a component of our quantitative result. And if our p-value is less than our critical value of 5%, for example, that we can qualitatively assert that our analysis is significant and our outcome is significant with regard to that quantitative analysis and qualitative analysis.
So finally, the conclusion. This completes the scientific method. It answers the big questions in everyone's minds. So you went on this quest to find answers. What were your answers? Was your hypothesis true or false? Why was that? What is a conclusion? It's a final statement based on experimental measurement and observations. You may be wondering how to effectively construct a conclusion. First, it's important to summarize your findings and then answer the big question: was the hypothesis proven? Was it true or was it false? And then you can continue on to answer why it was true if it was true, and why you think it was false if it was false. At this point, you can include some of your background information to validate your answers. And then you can go on to talk about the significance of your research. Why is it important that people have this knowledge? Why did you want to find the best way to make plants grow? Why did you want to know what can make flowers grow? And then you can talk about future directions, what you plan to find out, what questions have you gotten from the results that you've already generated, and what do you plan to do in the future to get more information or more knowledge on the topic that you were researching. And then once you have the conclusion, you can communicate your research and your findings to other people in the science community.
But apart from knowing what the scientific method is, it's important to understand the significance of doing science in this structured, organized way. Every one of the steps in the scientific method of doing things has an important role in making sure that we're not making a mistake in the process and reaching the wrong conclusion. If we draw a hypothesis and do some research without putting that idea to test, we won't have a solid scientific theory. The result will simply be something pseudoscientific, that is not verified, peer-reviewed by other experts, and will overall have little scientific value. Following the scientific method helps us avoid things like confirmation bias, where we actively try to validate our own preconceptions about how something works. Or it can help us rule out ideas that are unfalsifiable, or things that we simply cannot put into test. An example of that, which is used in Russell's argument, is the Russell's teapot, which he says, I can assume that there's a tiny teapot orbiting around the Earth between Earth and Mars, but it is too small for any scientific equipment to detect it. Such claim seemingly could be true, but there's no way to falsify it or verify it. So that makes it something of no value in the scientific studies. One of the other benefits of doing science in this structure is allowing for independent confirmation of experiments, where others can follow our own steps in our experiments step by step and verify that our results are reproducible. Overall, this really highlights the importance of the scientific method across different disciplines. And with that, our video on scientific method is concluded. Thank you for watching and have a wonderful day.